So last time we were dealing with trig functions, okay? You know, like sine, cosine, the good stuff. And the kind of examples we were working with were, suppose you had a trig function such as this example, sine of an angle, let's say we knew was 1/5, okay? Let's just assume that. We're going to find all the other trig functions, but we're not going to find what that angle is. All we know about the angle is that it's between 0 degrees and 90 degrees. That's all we know about it, okay? Okay, well, how do you solve this kind of example? I think I might have done this one last time, but I went through it kind of quick, so I think it'd be good if I went through it again. Okay, let me see, can everyone hear me? Yeah, okay. Good, okay. All right, so let's do it. And again, basically what you want to do is you want to draw a right triangle with the angle theta and the right angle, of course, such that this is true. Okay, so we want this to be true. Well, let's say we had this right triangle, okay? You know, we have the right angle. That's what this square here, the little square denotes. Remember, sine is opposite over hypotenuse. When I say opposite, I mean the length of the opposite side. Hypotenuse is the length of the hypotenuse, right? The hypotenuse is the side that's opposite the 90-degree angle. That's always the case. The other two sides, again, are opposite and adjacent. They're labeled that way relative to the angle theta. Okay, so we have sine opposite hypotenuse. So we can do opposite side as 1, hypotenuse is 5, okay? But again, if you want to figure out all the other trig functions, okay, what you want to do is get the length of the remaining side, which in this case is the adjacent side, okay? The one I labeled as x. Now, can you determine what this side, the length of this side, can we determine that? Well, yeah, because we have Pythagoreans Theorem. Well, oh, what did I do? Did I do something? I thought I pressed the wrong button, and it looks like I did not. Okay, cool. All right, good. Sorry about that. I thought I pressed the wrong button, but I think we're okay. No, if you can't see me or hear, or if you can't hear me or see the notes, let me know. You know, type in the chat or something. Okay. Again, we can find the length of that remaining side by Pythagoreans Theorem. Okay? So we can do that, and that's what I'm doing here. We have x squared plus 1 squared is 5 squared. Okay? X squared plus 1 squared is 5 squared. And we want to know what x is. So 1 squared is 1, 5 squared is 25. X squared plus 1 is 25, right? So we want to solve for x. So we want to get x all alone. Subtract 1 from both sides, okay? We get x squared equals 24. Then you take the square root. I simplified it. I thought that would help a bit. But you only have to simplify if I tell you to. So you could really leave it as the square root of 24 unless I tell you to simplify. But I did simplify. Yeah?
I didn't mean to cut you off, but I just have a question about the theorem. So like the formula is a squared plus b squared equals c squared. But
right.
what does that correlate to, like on the triangle? Like, is c squared equivalent to the hypotenuse, or does it not work like that?
Right. Well, that's a good question. C in that theorem, c squared, c is actually the hypotenuse, which is 5 in this case.
Yep.
And a and b are the legs. It really doesn't matter which ones they are. This could be a and this could be b, or the other way around.
Okay, so a and b, it doesn't matter, but the hypotenuse has to be c?
Exactly.
Okay, thank you.
You're welcome. Good question. Good question. Does someone else have a question or?
Yeah, I had a question. So theoretically, you could have put the theta in the top left corner.
If you wanted to, yeah. The only thing is though is that x and 1 would actually would interchange though.
Right.
Because sine of theta is opposite over hypotenuse, right? So opposite side would be 1. The side opposite theta, the hypotenuse is 5. So if theta was up here instead, then the opposite side would be here. And this would be the unknown side. But the hypotenuse is always opposite the 90-degree angle.
Okay, thank you.
You're welcome. Does that make sense or?
Yeah.
Okay. Yeah, let me actually draw this for, someone asked about Pythagorean theorem, which was a very good question. Let me see if I can draw it. Oh boy, it's not coming up. Wait, I can't draw, I know. Boy. Here's A, here's B, and here is our wonderful C. So basically, Pythagorean theorem says that A squared plus B squared has to be C squared. Okay, and again, as I said, I'm not sure who asked it, but it was a really good question. It really doesn't matter which leg you call A and B. You know, I wrote it as A would be X and B would be 1, but you could do the other way around if you want. You know, B could be X and A could be 1. C is always the hypotenuse. And Pythagorean's theorem is this. So that's what we have here. And that's what I'm using here. So the unknown side, in this case, which is the leg, would be, again, the square root of 24. I mean, I did simplify it because 4 is a factor of 24. 4 is a perfect square, okay? And so, you know, just like before, we get 2 times, just using like what we have seen before, we get the square root of 4 times the square root of 6, which is 2 radical 6. Okay? So, I mean, if you left it as the square root of 24, that's fine also. So again, I simplified it to be 2 times the square root of 6. So now, once we have this unknown side, in a sense, we're home free, right? Sine, remember SOHCAHTOA? Sine is opposite over hypotenuse, which we know. Cosecant is 1 over sine, right? But again, 1 over sine means you just flip it, you know, invert it. So 1 over 5 becomes 5 over 1, which is just 5. Cosine of theta, right? That's adjacent over hypotenuse. Adjacent over hypotenuse, right? So we have 2 radical 6 over 5. Secant, that's 1 over cosine, right? 1 over, you invert this, and you get 5 over 2 times radical 26. And tangent is opposite over adjacent. Opposite over adjacent, which is 1 over 2 radical 6. Cotangent is 1 over that, which again is 2 radical 6 over 1, which is just the same as 2 radical 6. Are there any questions about this? I know this isn't easy, believe me, especially in this virtual environment. I know this is not easy. I completely understand. I did post some practice questions from the textbook on Blackboard. You know, I updated those. So. Okay, but again, let me say it again because someone asked this and it was really good. You could have put theta up here if you wanted to. You know, if you wanted to, you could have done that. The only difference, though, is that the opposite side would be here, the side opposite theta, and the adjacent side, well, the hypotenuse would still be the same. So in this case, 1 would be down here, and x would be over here, because this would be the unknown side. I mean, you could do that, or you could do what I did. So, Okay, I was gonna have everyone try this one now. Again, if you try it out, give it a shot. Okay, think about it's not the hand in, so don't panic. Okay, let me just pause the recording. Okay, let me stop.